Hello everyone, welcome to this webinar on hybrid applications. My name is Artur Signell. I'm here with Joonas Lehtinen today, who is joining us from San Jose.
Hi everyone, great to be over here. So it's not that sunny morning here in San Jose, but I guess it's already pretty dark in Finland.
Yes. So Joonas, what are we going to talk about today?
I think that's a fair question when people have been asking what is this hybrid thing anyways. So let's see, can you see my slides?
Actually we can see you.
Slides first. Okay, thanks for noting that. Let's see, I'll switch over here. So the topic is hybrid applications, and before actually even jumping into the topic, I think it's fair to warn people that this is not the best practice that we are speaking of. It's more of an idea what could be done in future, how we could combine this unique approach that we have in Vaadin, basically building things on the server side with all the benefits of building things on the client side. So I guess it would be fair if you explain what we mean by client and the server side first. So first of all, you all have seen how rich web apps go. So basically you have a JavaScript layer, you have a communication layer, you have a web server and a backend server, right? Mm-hmm. So in this context we refer this client side UI to be all of the user interface layers related to building the actual logic in the client side. So that will basically be the web server and the communication and the JavaScript layer. So that's what we call here as a client side UI. And for the server side UI, it basically reduces the amount of layers to only one, making rendering and communications automated. So this is what Vaadin has traditionally been. A bit more into this. So if you kind of compare multiple approaches, let's say JavaScript and Google App Toolkit, these are clearly client-side UI approaches. So you write the UI on the client side, and then you have to support this with the communication layer and the web server layer. For Vaadin, you can basically skip all the client-side communications and the rendering, but you can also optionally implement it. So basically, Vaadin can also implement everything on the client side. But you can also do server side. So this basically kind of leaves you an option to choose either client side or server side. And both of these have benefits whether you choose one layer approach. I mean, basically letting the framework to do all the tasks for you, or you choose three-layer approach where you have all the control over what's happening in the communication and the DOM. So it's your choice to make. And what we try to speak over here is how can you combine these approaches? Are they fully separate, or is there any way of making a hybrid application, combining user interface on the client side and on the server side? And if it's even a meaningful thing to do. And as a kind of summary, why would you want to do this? So on the server side, you basically get maximum productivity. I mean, for the developers, you write minimum number of lines, you design minimum amount of layers, and it's easier to maintain. While as on the client side, you get to do all those things by yourself, and then you are the decision maker how these are done. So you have all the control. So Artur, would you like to add anything?
I don't know if I have much to add at this point. Maybe we should look at the architecture of how you could do something like this. I mean, I think many who are watching this are traditional Vaadin server-side users, and it's not really clear how or even when and if you should do this. But let's start with how. Yeah,
I guess this is more of a kind of just a statement what Vaadin is today already. So basically, in Vaadin architecture, you have to write the UI on the server side. You have to write the backend somewhere on the server side, whether that's in a different server or in the same server. And how you write the UI on the server side is basically composed that out of components. These components being like buttons and trees. All of them are just plain old Java objects. And then Vaadin takes over, renders these on the screen. Basically puts client-side widget for each of these components and guarantees that these two guys are kept in sync and creates all the communication between these. So this is how kind of server-side Vaadin is working, and your task is only to write those white boxes over there. And of course there is theming on top of that to customize the look and feel. But with Vaadin 7 we also had the possibility to write things on the client side. Namely, we integrated with Google Web Toolkit in Vaadin in such a way that we took a full copy of that, put that inside the framework, and now you have basically all the functionality in the Google Web Toolkit built in Vaadin. That way you can write logic on the client side. But if you do that, you can actually, you always have to also write the service layer. And I guess this is the focus of this webinar, how to write the service layer, how to connect these pieces together. And also to note, while we are pretty Java oriented, while we integrate the Google Web Toolkit that basically compiles Java to JavaScript, we at the same time added support for JavaScript for all the same communication mechanisms. So whatever we are discussing today in context of writing these things in Java, you can also do that in JavaScript. So that leaves quite a bit of freedom for you to choose how you work.
So actually, when we are talking about implementing an application, both then now separately, or parts of it on the client side, parts of it on the server side, I think one of the interesting questions here is actually how do these communicate together, or do they communicate with each other?
Exactly, and we are just kind of speaking about different, I would say, tools for building the communication. And what we present is just one way of creatively using those tools to build something that is not that typical on the web today. But I guess you have many more ideas how to actually use the same tools to build something else. So just pick and choose whatever tools are in the Vaadin toolbox and build something new and amazing with these. But let's go to the reasons why we actually want to do, why would we want to combine these two things? So I guess the client side, there are things like offline mode. It's pretty clear that if you're building your application on the server side, it won't be working offline. If the server side, if all the logic is in the server and you don't have a communication to the server, you don't see anything on the screen. So clearly, offline is a hard case where you want to and must go to client side. Also, while Vaadin is pretty optimized for sending super small packets over the wire, keeping the communication open and so forth, it's you can always make the UI faster by not doing any communications. So that way, let's say gaming and that kind of things where the latency is super important, you won't be affording to have 100 millisecond delay in the communication layer, then you could optimize this part on the client side. And the third part is scalability. Basically, when you compute more on the server side, you compute more on the server side. So if you take this out of the equation, do all the computation on the client side, that allows you to scale more, basically using the power built into browsers. Should we add any cases over here, Artur?
I'm not sure. I mean, the scalability, it's interesting. You have full scalability if you skip the server, but you can't really do that. So, of course, the server side is the bottleneck if you have really many clients.
Yeah, and on the test that we have been doing, most of the cases, the scalability bottlenecks are on the logic and storage layer, not on the UI layer. It's pretty easy to just throw more front-end servers on front of the back-end. But if you just look at one front-end server, it's for a typical server, I would say like 60 16 gigs of memory, you could get around maybe 10,000 concurrent users on a server-side approach. So clearly, if you want to build something much more scalable and you cannot throw tens of front-end servers in your application, then you need to optimize over there.
Yeah.
For the latency part, I don't see that much Vaadin being used for gaming. So those low latency interactions are more like, especially if you are on mobile and you want to have some user interaction to be super fluid. You have built this on the server side already, and then you think that, hey, maybe we should optimize this and save one round trip to the server. So later on you can maybe move that interaction to the client side.
Yeah, so it's kind of an optimization in many cases, that typically the server side is okay, but then for some certain parts this might be good.
Yeah, and my kind of gut feeling is that most of the cases you want to kind of postpone the optimization. First implement a good application and then identify the few parts that need optimization instead of trying to kind of pre-optimize everything by writing everything on the client side.
Yeah.
So that brings us the server-side part, and the best use case for server-side is to use it in places where the client-side is not required. I mean, the benefit of server-side that you basically get the user interface for half the cost for implementation and maintenance. So it would make sense to use that everywhere if possible, and only when it's not possible to use it somewhere else. And of course there are other benefits as well, like that you keeping the logic on the server side. It's pretty much more secure environment than sending all your UI logic to the client side. And of course you can utilize the full Java platform, write things on Scala language and so forth. So I guess the theme of this webinar is if we could combine these both sides, we could actually get the benefits of the both sides in the same application. Clearly that would add more complexity, as you would have to understand both models. But for a few applications, for many applications, it actually makes quite a bit of sense to take the benefits of the both sides.
Yeah. So do you have any example of any such applications where it actually could be useful? Because if I think about my standard enterprise applications, I'm not really sure.
Yeah, that's basically in your enterprise application. If you have a good connectivity, there is few reasons for actually adding client-side parts. For an application where the connectivity is not given, then the latency issues start to pile up, and also then offline mode makes more sense. And that, in most cases, that's mobile. So Artur, actually, could you show the parking demo that we have?
Actually, I'm not sure if I have it here. If you have it there, you could show it.
Okay, I can show it. So, or I could actually just show it from the demo Vaadin commit, so everybody can test it by themselves. So just a second, I'll add it here. Actually, so I'll just put the screen sharing back on. So for this demo application, what we wanted to do was basically show basic functionality of Vaadin TouchKit. So this application is a parking management application where you can basically see what are the parking tickets given in a given region, see some working shifts, see some reporting. It's mostly meant to be run on a smartphone. You can also run that on a tablet, so it's a responsive application. Uses the space in an optimal kind of way. But the interesting thing over here is that writing a parking ticket, you might be somewhere in like underground parking garages where the connectivity is really poor. So that way it will make sense to actually guarantee that you can always write this parking ticket whether you have network or not. And the key over here is that the first view over here is basically written on the client side. So I can save a parking ticket. Let's see what I'm missing. I'm missing the address. And it goes direct to the database like this. But if I happen to be running the same thing on offline, then this actually saves the ticket to a local storage database. And when I go back online, it synchronizes it with the server. And this is totally automated. Actually, I don't want to kind of show this right now as I don't want to go offline. It would be a pretty embarrassing to drop out of the webinar at the same time. But you can just go to demovaadin.com and choose a parking ticket application, try it yourself on your mobile phone or even on a desktop.
Yeah, but basically when you go offline, you will have like this smaller version or reduced version of the application available, so this map view won't be available to you offline. It will only be this ticket view.
Exactly. So basically when it detects offline, it just grays out all the parts of the application that are not available on the client side. And when it detects online, it actually asks whether you want to go back online so that it doesn't interrupt you while you would be, let's say, writing a parking ticket and the connection gets back on. And when you switch back to online, it just synchronizes and enables all parts of the UI that are available again.
So this is actually a choice that has been made when making this application. I mean, you could make some of the other tabs also available offline if you like. But here the basic decision then has been that this is the only view that you really need to be able to use offline. You don't necessarily have to be able to look at the stats or the last cached version of the stats offline.
Exactly. But it's a bit too complicated application to go through like on a code level on this webinar. So we wanted to do something simpler. So let me show that. Or actually, I show the URL to this demo first. So it's demovaadin.com/parking, or just go to vaadin.com, click demos and choose parking. But we're actually kind of taking a look under the hood. We drew quite a bit simpler demo application with Artur. So this is, I would say, the simplest possible CRUD demo, just listing an address book. And just for the demonstration purposes, we implemented this 4 times. So once on the server side, then once on the client side using GWT-RPC, again once on the client side using Vaadin connectors that we'll be speaking a bit more in a minute. And for the 4th time, we also implement this with an offline mode. So this kind of gives you a way to compare what's the complexity in all these different implementations, what are the differences on these implementations. This is not the real application by any means. Nobody wants to have the same UI 4 times with 4 different implementations on the same application. But it gives quite a bit of perspective, what are the differences in these approaches. And at the same time, it actually gives you quite a bit powerful way of evaluating what are the benefits of the server-side model as well, because it's strikingly simple when you're comparing that to the client-side models, especially for the offline. The source code is available at GitHub on my GitHub repo. We'll post this URL back to the Vaadin forum so that you can find it from there. But as a background, the data model looks like this. So this is the simplest possible backend to have. We have address objects over there. We have a backend interface or facade that basically kind of just gives a backend API, and we have a simple mock-up implementation of this API. So that is basically shared and used by all the different implementations on the for this UI. And the first implementation to speak of is the server-side implementation. And that's actually pretty straightforward. There is just one class, address book editor class, that implements a Vaadin UI and connects to the backend directly. Because this is run on the server side, you can actually synchronously and securely connect directly to your backend implementation and backend facade. Artur, would you care to
Yeah, I was just going to suggest we should take a look at this class. So I should have it here in my Eclipse. One moment. Okay, so this is the server-side implementation of this address book editor. If you're familiar with Vaadin, it should look pretty familiar to you. Also, if you're
actually, if you're familiar with any component-based
framework, if you're familiar with it will also look familiar to you. So, what do we have in this class?
Or even Swing.
We have some fields where we basically declare and instantiate our components that build up the UI. If we go a bit down, we have one method where we set up the UI, we add the components, build it the way we want it to look. This is just some more or less standard code for adding components and setting some sizes.
Hey, one comment over there. Don't take this as a best practice how to organize your code for the UI layer. We just wanted to keep it super simple. So in practice, you might want to control like using MVP or at least somehow structuring your user interface. But this case was so super simple and small that we thought that it's actually more clear to just put everything in one class. It's just like 170 lines.
But please don't make applications that are one class. Okay, then we have one method here. It basically gets all the addresses available in the backend service, and it populates a bean item container using these addresses. So it sets up the data source for the table we have in the application. And
the key over there is I think this is quite critical to understand. When you bound to the backend, you can actually do backend calls directly and in a synchronous fashion. So you don't have to set up any kind of asynchronous callbacks. You can just access the service layer right away, expect to get the answer right away, expect the service layer to be reliable. It's not going over a network or anything like that. And this makes this code super simplistic when you're comparing to going over a network and planning strategies for dropped connections and so forth.
That's true. So then the third part here, we have some logic. This is also, well, it's mostly redirecting the click events to different parts here, or calling the backend again directly like this. If we click the delete button, we just pick the address we have selected and directly call the backend to delete it and then refresh the list of addresses.
So this is pretty normal asynchronous UI practices. Just listen for events, and when the event happens, then you modify the UI. And I think we probably should change the example to use Java 8 because by having Java 8 lambdas around, it simplifies the code quite a bit. All those anonymous inner classes would go away, and this would actually be more compact than JavaScript.
Yeah, that's true. You could actually remove almost or most of the code in this method that sets up the listeners.
But I guess that's more or less is the server-side approach. It's super simple. It's one class. And how many lines did you have over there?
Yeah, we have some more for handling the form, binding some fields, but all in all we have like 190 lines of code.
Including imports?
Including everything. Not many comments, but...
actually, if you could run this and show how it looks like.
So, let's see. Yeah, this should be it.
One thing to note, when we... The purpose was to implement the same UI 4 times and have it exactly the same. We ended up actually having quite a bit more functionality on the server-side implementation. All those minute details like lazy loading more data and hiding CRUD editor while we are not selecting anything. So it's not a totally fair comparison to just compare the number of code lines, because the server side is having quite a bit more details and functionality than the rest of the implementations. But it's more or less the same.
Yeah, it's still a basic CRUD.
Yeah, and I think when we have this new Vaadin grid available, basically completely new generation grid component, data grid component, we could actually replace that into the example. So that way we would have exactly same grid implementation in all of these versions, having the same grid on the server side UI and client side UI. Then we could have these on the same like feature parity with each other.
Yeah, that's true. But I think maybe we are getting a bit ahead of ourselves. Maybe we should have a look at the client-side version, where there's actually another table implementation used. But
yeah, I can show that on the slides. Yeah. But all in all, the functionality over there is that choosing one address, editing the address, saving the address back, creating new addresses. So that's basically it. Yeah. But let's go to the client-side part. So that was the server-side implementation, just the backend and one class for the UI. For the client side, interesting thing is that we basically have the same class, but on the client side. There are some minute differences because of the different APIs, and also some like logical differences because we are communicating over the wire and need asynchronous callbacks. But pretty much these two UI classes are logically the same. The difference is basically the communication from client to the server side. So first of all, we have to place this address book editor somehow on the screen. In this case, we are using Vaadin as a kind of foundation of this example. So we are using Vaadin UI component as a view that places this on the screen. If you would do a purely client-side implementation, let's say with GWT, you would actually, this view would be just a web page, static web page, putting the UI component over there. You need something. In this case, we add Vaadin connector that basically creates the address book editor widget on the screen. If that would be a pure GWT application, we would have an entry point that would actually do exactly the same thing. Find a div, call that the root panel, and put this widget inside the root panel. So basically you would have the same PCs with a bit different names. These are simple PCs, just putting the widget on the screen. There is no kind of communication yet between the client and the server side. The communication itself is basically first you have to define the service interface that you want to publish on the net. So this is a different thing from the backend, because this is the API that you publicly put available on the web, not the service interface that you have on the backend that might have some functionality that you don't want to expose to the web. And then you have to actually implement this interface. In GWT-RPC, there is a handy RPC servlet superclass that can be used to implement this, basically this web API, and the implementation itself is basically just the implementation of all those. What happens when any of these published APIs are called? So that's the kind of the service part. But the funny thing is that you cannot use that either directly from the UI, because this is synchronous, and on web you need asynchronous interfaces. So basically you have to convert the API to its asynchronous version. Basically move all the return values from all the methods to asynchronous callbacks. Artur will show the code in a bit.
Yeah.
And then you can just use the asynchronous interface from your UI. Luckily, this proxy is auto-generated, so you just say to GWT that, hey, please create proxy from this interface, and it automatically creates it for you. But as you can see, there are quite a bit more pieces on your stack when you're building the thing on the client side and communicating over the GWT-RPC, or basically communicating over any AJAX-based communications, logically the pieces are always there. But
okay,
maybe Artur, you could show that.
Let's have a look at the code for this version. So we're looking at the GWT-RPC example. If we start from, well, we can start from the service interface. It's actually pretty simple what this service interface does. It defines the path on the server where this will be deployed, and then it just provides basic CRUD operations. Find address, store address, delete address.
So this path is basically the URL where you can access these web APIs.
Yeah. Well, okay, then we have the asynchronous version of this. It adds some just support for some callbacks, but then we have the actual implementation of the service, which is also, well, it's quite simple because it's mostly calls to the actual backend, and then in some cases doing some reformatting, but it's not doing very much.
Of course, the authentication and authorization should be done on this level as well. That now it basically allows anyone on the internet to make any API calls to our backend without any filtering, and that's not the purpose.
Yeah, there's no access control here, just to keep it simple. So if we look at the editor now implemented on the client side, we can see that actually it resembles the server-side version so far pretty much. We have the same basic needs here to create the components, create the layouts.
The difference is basically are from that we are using GWT widgets instead of Vaadin widgets over there, and the APIs are a bit different.
Yeah, that's true. And also, well, one thing where you see at least that you have a lot of more lines of codes is initializing the table now on the client side, because on the server side we can just let Vaadin handle it, give the beans to the bean item container, connect them to the table. But here on the client side we actually have to do some small implementation for each column in the table, so we have to specify how we get the first name and how we get the last name from the data objects we have. And then the other significant difference here is, for instance, the update address list. We can no longer just call the service get addresses and add them to the table. Instead, we have this asynchronous way of fetching the addresses from the server. So this call actually does then an RPC call to the server, and we specify what we will run when this call returns from the server. And also another difference here is that this call to the server, it can actually fail, and we have to somehow handle this failure in the connection for this single RPC. If we look at the Vaadin version, then the framework itself will take care of problems in the communication.
Yeah, that's kind of, we get many things for free. When the framework kind of owns the rendering and the communications, there are many details that are taken care of automatically.
Of course, here we have more freedom of handling failures in any way we see fit, but typically it's not something that you want to spend too much time and thinking on. But actually applications, in many times they have such a poor decisions what to do on a failure as we did over here. We just put a window alert and say that, hey, there is a problem in the connection. Yeah, that's not very user friendly.
I guess that end user, yeah.
Okay, but more or less we have the same code. We have the same click handlers calling asynchronous methods. We update visibility and so on. We set up a form, slightly different way than on the server because we don't have the same type of binding data to components here. But in the end, we're doing pretty much the same things. It requires some more lines of code here for all these various reasons, so we end up with something like close to 300 lines of codes for this version.
Yeah, and just to remember, it doesn't have all the functionality over
Yeah,
here. But if you could switch back to my screen, I could kind of actually show this complexity.
I was actually going to show the user interface first, how it looks like. So this is basically, or this is the GWT-RPC version of this application. It looks and works more or less the same. Here we can see the table looks a bit different because it's not Vaadin table we're using here. But the basic functionality, it's still here, and we can do all the same things.
Yeah. Okay, let's go forward.
Right, so let's go back to the presentation.
Yeah, so I guess the first thing to note over here is the complexity. As on the server side, you have like one class on the UI layer and 190 lines of code. And on the client side, this GWT-RPC implementation has 4 classes, 2 interfaces, and maybe around 500 lines of code or so. So more or less, you're looking at 3x in a complexity if you're measuring the complexity just by lines of code and number of classes. Of course, this might not be the best measure for the complexity, but these actually translate to really real-world terms on debugging and implementation and maintaining this. So more complexity, more work to actually do for the actual implementation.
Yeah, so even though for instance, the service implementation on the server side is really simple, mostly forwarding calls to the backend, but we still have to implement that.
Exactly, and then you have to start thinking how to do authorization, authentication over there as well. So it's not just forwarding the calls, but also thinking of the security that would be automatically handled for you on the server side. So let's go a bit forward and see the next alternative, that being how to use Vaadin connectors for doing the client side. So we are basically doing exactly the same thing as we did with the GWT-RPC, but now using Vaadin toolset for building the communication layer. For that, a bit of a background. The origin of this tool chain is basically connecting server-side components, namely UI components like buttons and trees and so forth, with their client-side widgets. And the connector is just the class that handles the communication between those two guys. And for that, we built 2 different communication channels. So first one is RPC. So this is pretty much the same as in GWT-RPC, but it's a bit simpler to use because it's just like one directional while the GWT-RPC is bidirectional. Let's get back to that in a bit. But then there is a super powerful way to send data from the server to the client side called state. And this state is basically just plain old Java object that can contain any kind of values, and when you make any changes to that object on the server side, you receive those changes right away on the client side. So that way it's really simple to send data over the wire from server to the client side. For these, you could actually, let me show you a simple demo. So you can actually go to Vaadin sampler, and there is example called state, and for that you can try this out by yourself. So there is a to-do list widget. This is like client-side GWT-based widget that knows nothing about the server side. There is a connector, and there is a server-side class with that kind of API as we see on the right side. And you can just try to, with this API, to modify the state that is visualized in the middle. And this state is just a linked list with photos in the list. And all these changes are sent over the wire to the client-side widget. But you can go into details by taking a look at the source code from here. And also you can play with the RPC version of this, showing namely how to send calls over the wire in both directions. Here I'm sending from the server to the client side, and I can also send from the client to the server side. So take a look at those sources as well. I'll switch back to slides. I don't think that we actually have to go into details how the...
No, I don't think we have to do that.
Calls are formed. This is pretty basic stuff. But just to kind of show these two approaches side by side. So now we have this GWT-RPC version that we were looking previously on the right side, and then we have the connector version on the left side. And as you can see, we are basically not removing any of this complexity. These are pretty much the same from the complexity point of view. The code is just organized a bit differently. On the connector version, we have one RPC interface for each direction, but we don't have to create asynchronous versions of these. And we also have this state facility that we can use for sending data over the wire.
There is one difference though, because here in this connector version, the RPCs are really tightly coupled to the connector, so we don't actually make any public endpoint available for the RPC calls. They just kind of stay inside the connector and inside the framework.
Exactly, and that basically kind of gives you all the security benefits of the server-side programming over here as well. So basically you are within the context of the session. But there is one big difference, and that's namely that you can actually use push built into Vaadin with this connector version. So even if you have just a client-side GWT application that you have been building within GWT-RPC, the benefit for actually using Vaadin toolset for the same application would be that you would basically get the push channel for free. But in order to use this push channel, you would have to use those connectors. So I guess this kind of concludes the first three versions that we do have. Or do we want to say anything else about the server side or either of these client side versions?
I don't know. One thing that could be mentioned is maybe, or actually, should we have a quick look at the code? We skipped one part of the code, which is actually how do you get in the code this GWT part into your Vaadin application. So we looked at the address book editor, but
yeah, you can show that.
Could have a quick look at this. So if we look at our whole application containing here all these 4 views, we have it's based on one Vaadin UI class called Hybrid UI here. And it's pretty simple. It's based upon a Vaadin navigator to which we have added 4 different views, one for each of these versions. And if we look at, for instance, the GWT-RPC version, so we have here an address book view class for the GWT-RPC version, which is actually a Vaadin component and a Vaadin view, but it doesn't really contain anything. So it's like a custom Vaadin component, because to this address book view we have this address book connector on the client side. So this connects to the view, and actually this connector then creates the address book editor widget, places it wherever we use the address book view on the server side. So
you could actually take a kind of you could actually think this as your client side implementation of the UI. You can think it as a mega component for Vaadin, in a way that it would be only one widget, and then you are adding a server-side component that corresponds to this whole view at once.
Yeah.
So this kind of moves from communicating the actual context of the text fields and buttons and so forth from back and forth between the server and the browser actually communicating the end result of this user interface. For example, in this case, that would be the add new address or change this address line somehow to our higher level operations.
Yeah, that's true. And this will look a bit different if we look at the connector version. We will have some more code here because in this version the RPCs will go through the connector. So we will actually handle the RPCs inside the connector here. And it actually also uses, well, the state, so it will handle, well, all the communications will go through the connector. But maybe we should go now to the fourth version, which is kind of the most interesting version.
Yeah, the offline. Actually, version. Before going over there, just as a reminder, if you have any questions about anything we have been speaking here or something that we haven't been speaking, feel free to write those questions on Vaadin forum and we'll try to address those questions during the webinar or right after that. There are some questions that we have got from the sign-up form. Krishna was asking that he had been basically using the Vaadin for 2 years, haven't been using GWT at all, and asking that what would be the actual reason for using GWT widgets directly, not going through the Vaadin chain. And I would say that if you have been happy on the server side, and if you don't have any kind of bottlenecks in your application, there is no reason to go to the client side. So,
yeah, so I think we actually talked about those when we talked about the good parts or the reasons for going to the client side. I think these apply pretty much in this case.
Exactly. So the second question is from Kent. Do you have to take responsive design into consideration when writing hybrid applications? And the answer would be no, there is no connection between these two things. Whether you want to build a responsive UI or not, it's a separate choice. It's always truly recommended to build responsive UIs so that they fit a bit better on mobile devices as well. And there is an exciting Vaadin add-on called Responsive, and you can use that to ease the building of the responsive layout. And actually this add-on is integrated right into Vaadin 7.2. That should be out. Actually, Artur, when we have Vaadin 7.2 out? 7.2
yeah, well,
out.
Slipping a bit from the topic now, but we are the 7.2 beta should be ready at the end of next week, so we should have it out then pretty soon.
Yeah. Greg was asking about the Maven, how this should be done with Maven. This example that we have over there, it's actually written with Maven, so you can just pull the example from GitHub and package that and then run that with JDRun, and it should be pretty simple. Yeah. I don't know, this is probably not the best example how to write Maven POM files, but...
Yeah, but I'm running the applications through Maven right now, so it works.
And the Roger was asking, will the app with huge amount of UI perform fast? This is a bit vague. If you have a really big enterprise application with hundreds of different screens, in most cases a server-side version of that would be actually faster than client-side version. And the reason is that on the server-side version, you keep all the UI implementation and logic on the server side. So basically you don't have to send this logic over the wire. While on the client-side version, you would actually have to write this or implement this in a way that is sent over the wire, and that, in the end of the day, would contribute to the size of the JavaScript files loaded from the server side. So with hundreds of screens, you might be seeing like multiple megabytes of JavaScript loaded from in the beginning of the application, while as in server-side version, you would just load the implementation of those widgets shown on the application, and that would be from 100K to maybe 300K of JavaScript and CSS and so forth. But let's jump into the meat of the webinar, offline mode. We are already pretty late in the webinar, so we took quite a bit of more time with the fundamentals behind the offline mode. So let's see if I could actually show the offline mode first.
Yeah.
So let's see, localhost 8080, open up the offline mode. So this is, the UI itself is exactly the same. I can just run this while I'm online. The thing is that I can also jump to offline. So there are two ways to jump to offline over here. So first one is if I click the simulate offline button, what it does is basically switches to new URL, basically /offline.html, and this is actually our design choice for this particular application, so that you can easily go to a separate static HTML page that contains the same application. And this HTML page basically loads the same UI widget over here. And if I now do some editing, let's see, I edit this Olivia to be Joonas, save it, I can see the edits on the screen, and when I go back to the online version, this actually sends these updates from my local storage database inside the browser to the server side.
Yeah,
so now I see this on the here as well.
So when you did the edit operation in the offline version, what actually happened was there were no server visits, but instead the local storage version of this data was updated so you could see the new data.
Exactly. So we basically are maintaining two databases, one on the client side and one on the server side. If I would in Firefox choose work offline or cut the cord, the application actually detects that, hey, now I'm on the offline. It asks you, do you want to go to offline mode? And basically goes to the same URL. So there is kind of automatic detection of offline. Same if I go back to online, it asks, hey, if I want to redirect back to the online version, and I can go over there. So I guess this is pretty much how it looks like. So let's take a look of what's under the hood over here. So let's see. Maybe we should start from the slides.
Yeah,
first.
sure.
So there are 4 different parts that need to be done for the offline version, and the first one is bootstrapping the offline version. So how we do it is that in HTML5 there is a new facility called cache manifest that basically defines which resources should be cached on your web browser for a longer period of time. On a static web page, you could declare this by just adding manifest attribute to your HTML file. On Vaadin application, there is a bit of extra trickery to actually modify the generated web page, but in the end of the day, it just adds this on the HTML tag as an attribute. In the cache manifest, you basically list all the files that should be cached and then say what files are on the network version. So the next step is basically when you go to this application and then you open up Vaadin application, Vaadin always loads this widget set. And we want to kind of add a customized entry point for our widget set that basically detects whether we should be running the offline version or the online version. And this is by adding a new entry point class to our widget set definition. And we also have to use this Vaadin widget set instead of the default widget set, so that we don't have 2 entry points for the same application.
So if we would actually use the default widget set here, we would have 2 entry points and we would start rendering both the offline and the online version at the same time.
And the third thing when this boots up is basically if we are on the offline mode, it loads application configuration, and on the module load we just add our address book editor widget, client-side widget, on the web page. So basically the root panel is just one div on our static web page, and we add the widget over there. I think that we shouldn't actually jump into code for this, because this kind of gives you a better overview than looking all the minute details on the code. But for looking at the details, just pull the GitHub project and take a look.
Yeah, I fully agree.
In the details. So the next thing would be how to detect the offline. And this is actually pretty simple in web browsers. There is online property for Window Navigator, and it basically just says true or false, depending on whether we are online or offline. And you can also listen for changes on this status. And in this example, in the beginning, when we are loading the application, we look whether we are online or offline and redirect to correct URL for online mode or offline mode. And afterwards, we can listen for the changes on this online status and redirect to a correct URL, or do this switch manually just by typing a new URL over there. For this, there are two classes, offline redirector and offline detector in the code, but this is pretty much it. So I don't see that there is point to actually look these either on the code level. So I would say the most complicated part of offline is managing persistence. So would you, Artur, want to kind of explain your persistence implementation?
Yeah, it doesn't look very pretty when you look at it this way, but the basic problem, of course, is you are offline and the user does something and there is data that should go to the server at some point, so you need to store this data in the browser until you are online again, so you have the connection. In this example application, it was implemented in such a way that, well, we have three basic operations: delete, edit, or delete, store, and something else. But basically the implementation, it converts this operation, it serializes them to a JSON format, because the local storage in the browser, it's more or less string based, so we cannot store anything complex directly here. So when we are offline and, for instance, click on save in the user interface, we will actually store all the data related to this save operation in a JSON format in the local storage in the browser. And we can store multiple of these, so when we get back online, we just purge the queue that we have stored these operations in. So basically, we are doing a playback of all these operations that took place when we were offline. Now, the interesting part here is, of course, when you have multiple users who are offline and do these kinds of operations. And the interesting question is what happens when the users go online and have modified the same data.
This is probably the largest problem in the offline mode, and we haven't done anything for solving this problem in this example. So the merge logic is always something application specific and use case specific, and you have to always do it by yourself. Yeah, so in this case, we just override the later changes are overriding the previous changes, but probably you would like to at least notify the user that there are multiple versions of this and there is merge conflict, and you should somehow, in a meaningful way, handle it. The end user must know that there are multiple versions and he's overriding somebody else's edits on the same data.
Yeah, that's true. It can depend on the application, of course. In some applications, this really simple strategy can be just fine. But typically, it's bad user experience if your data just disappears.
So, as a summary for the offline, you basically have exactly the same Vaadin connector version as you had previously. You have the same backend, you have the same UI, you have the same communication layer here on the left side. In addition to that, you add some extra bits for offline. Namely, you have offline local storage in your web browser, you have a data store class to manage this offline storage and synchronization. And then you have offline detector logic that basically guides you between the online mode and the offline mode. So that are the extras that you have on the client side. For the server side, you have two extras. You have to have some kind of way to bootstrap the offline. In this case, it's just a static web page called offline.html. And also, you must have cache manifest to guide the web browser to actually cache all these parts so that you can actually start the application without network connection. So I guess that would be like the overview of the offline mode. And the question goes, what it does for the complexity? So let's see. So first of all, you need client-side UI as a basis. You add offline detection, offline bootstrapping, local storage, data synchronization, maybe use modification logs as we have done over here, as well as some kind of sharding logic. You don't want to replicate the whole server-side database to the web browser. There are limitations on how much data can store on the client side, and it wouldn't be effective to send big databases over the wire anyways. And you need some kind of merge logic. And here we don't have any kind of exact numbers on this, but the gut feeling or the kind of rule of thumb is it's at least twice the complexity to build offline mode capable UI than to build the same UI on the client side. And when you're comparing this to the server-side implementation, basically remembering that the server-side implementation had 1/3 or under half of the code lines of the client-side implementation, you could safely say that the offline implementation of an UI takes at least 5 times the effort to build the same UI on the server side. And I think this is the key takeaway from here. So if you stop and think about it, if you're in your application, there are 5 views, or let's say 4 views as we had on the parking demo. Instead of implementing all of these views on the client side with offline mode, you could choose just to implement one of these views on the client side, spend that 5 times extra complexity for that view, and have rest of the views done on the server side. So the end outcome would be that you would be quite a bit faster in implementing the whole application when you would kind of carefully choose which parts actually have to work offline. And in many cases, things like mapping or reporting doesn't work offline anyway, so using architecture that forces offline for that kind of use would be just extra effort spent for no gain. So how could you use this today, or could you use this today? I think we should first repeat the warning. This is just an idea, not the proven best practice. So I think the fair recommendation would be not to start building your production applications on top of this idea yet, or if you choose to do this, be careful because there are some kind of hiccups in this approach. At least if you are doing it in a way that we did in this hybrid example application. But there are multiple reasons why you want to use these tools. So first of all, if you have a GWT application and you want to get benefits of the server-side programming model, namely the productivity on the server side, with these tools you can start adding server-side UIs over there. Or if you're using Vaadin connectors for your GWT application, you can start using Vaadin push channel as well. So that's kind of quite clear benefit. If you are today building server-side applications using Vaadin, that way you can start adding offline modes to your existing applications. And also if you have a Vaadin server-side application where there is a part of the UI that should be faster somehow, where you should reduce some latencies, this is a way to actually optimize the communication for those parts and make it as fast as a pure client-side application. So I guess these are the reasons to start using some of the tooling today, and these are the warnings for using some of the toolings today. So we are. I think the biggest hurdle at the moment is that Vaadin client-side widgets, Vaadin widgets, they don't have a proper client-side APIs yet. We are working on this, and we hope to have proper client-side APIs in the future. But at the moment, you would be mostly using GWT widgets on the client side, not Vaadin widgets that you have been used to be using on the server side. There are no tutorials at all but basically you could use this hybrid application as an example of tutorial. The theming is not unified. There are different ways to theme client-side parts and server-side parts. Offline detection is something that you would have to do by yourself. You can copy that from the hybrid example. Manifest generation is not there. You would have to maintain the manifest by yourself by hand. So there are multiple things that you would have to consider, and some of these things are a bit overwhelming. But if you choose to try it anyways, download the example and start hacking the code. There is also a shortcut for you. So basically this parking demo, it wasn't built like this. We were using Vaadin TouchKit to build this demo. And Vaadin TouchKit actually has many of these features built in, like offline detection and helpers for offline storage.
And actually
many of these
cache manifest generator also.
Yeah, so the tools are over there, but they are not in the Vaadin core framework, they are in Vaadin TouchKit. So if you want to use this today, and if you want to use this for mobile applications, then you should consider using Vaadin TouchKit for it. You would save quite a bit of trouble, and the documentation for the Vaadin TouchKit can of course be found from the book of Vaadin. But I guess that's more or less what we wanted to say. Let's see if we have any more questions. We don't have any more questions. Any closing thoughts, Artur?
I don't know. We have been going on for a little more than an hour, so I think maybe we should just wrap it up here and use the Vaadin forum thread for additional questions and discussions afterwards. So if you have any more questions, just post them there and we will monitor the thread and try to answer them as good as we can.
And also, if you hate this idea, please post that as well on the forum thread. Feel free to say that this idea is really bad and nobody should do it like this. Or if you love the idea, please communicate that as well. It would be great to actually hear from you that this is something that we should do. Or if you think that this is something that should be part of the core Vaadin framework, that we should support this really well in the core Vaadin framework, go ahead and say it aloud as well.
And of course, if you have better ideas on how to do this, please tell us about those also.
And I think that the key would be if somebody knows how to solve this merge logic in a generic way, that would be great to
well, then you will be rich anyway.
Yeah, I think it's more of an NP-complete problem.
Okay, but
thank you
for viewing and have a nice day.
Yeah, see you online on the Vaadin forum thread.
Bye-bye.